Hello, it's time for physics again. Today we'll be looking at quantity. What is quantity? What is quantity? A quantity is a measurable property of a system or an object expressed as a numerical value with a corresponding unit. I will take it again. A quantity is a measurable property of a system or an object expressed as a numerical value with a corresponding unit. We have quantities like length, length is a quantity. So, and length is measured in meters. Length is measured in meters. We have quantities like mass. Mass is measured in kilogram. Mass is measured in kilogram. We have quantities like time. Time is measured in seconds. Now the symbol for meters is lowercase m in lowercase, m in lowercase, kilogram, k and g in lowercase, second, s in lowercase. These are their symbols. These are the names of the units to measure them. They are in meters, and these are the quantities. So we call this the quantities, Q, and the unit, and the symbol. So, I'll go back again. A quantity is a measurable property of a system or an object expressed as a numerical value with a corresponding unit. So if I measure the length of this pen, if I measure the length of this pen, if I measure the length of this pen, I can take the length of this pen to be in centimeter, probably the length of the cover of the pen. Okay, let's take it about 5.6 cm. The length of the cover of my pen is 5.6 cm. The length of the pen itself is about 14.5 cm. So if I put the two of them together, it is about 14.7. Yes, about 14.7 cm. Let's approximately say 15 cm. So you have the length of my pen is approximately 15 centimeter. 15 centimeter, which is the same thing as 0.15 meter. 0.15 meter. How did I get 0.15? What I did was simply I divided 15 by 100. 15 by 100. That is 100 centimeter is equal to 1 meter. So I say 15 divided by 100 is equal to 0.15 meter. It is most preferable that our records and our measurement are in SI unit. The meter M is the SI unit for measuring length. So if we want to measure length, let's see how we can always bring it down to meters, except it's otherwise stated that we should leave it that way. So other ones, you have the kilogram, you have the second, kilogram for measuring our masses, second for measuring our length. Length is the distance from one point to another. One point to another, that is length. The distance from one point to another. The distance from this point to this point is about 16 cm. It's about 16 cm. So length is to measure. Then mass is a measure of the content of the material. Mass is a measure of the content of the substance, content of the object, content of the body. So what did we use to produce this plastic? The chemistry of this plastic is what we are trying to measure in terms of mass. The things that make up the chemical constituent of this plastic is what we are actually measuring. It's different from weight. Measuring weight is trying to measure how the amount of gravitational pull with which the force of gravity is pulling the cover of pen towards the center of the earth. So it's different from mass. Mass is measuring the amount of substance, the content that a body contains. Then time is trying to measure the quickness of actions, the quickness of movement from one point zero to another point. The quickness of actions, the quickness of movement. That is time. Now, we said that this is quantity, length is quantity, mass is quantity, time is quantity, and we have the units for grading them. We use this unit to say this is the amount of length. We use kilogram to say this is the amount of mass. We use the second to say this is the amount of time. You want to boil your eggs and you want to spend about 15 minutes. So you set your seconds, your time, to measure the time. You want to cut chicken. When you are celebrating, you want to cook your chicken, you should know the mass, the kilogram. Usually, what we measure, what most of us measure as kilogram of our chicken is our Newton. We measure our weight. However, in converting masses to weight and weight to mass is common. In measurement in the market, measurement in industry is not completely the same as measuring in measurement in the laboratory. Most of the teaching here are very much applicable in our laboratory. Measurement in our laboratory, we can decide to use watts to measure power in our laboratory. But in the industry, excuse me, in the industry, we can use horsepower to measure. So when measuring power, the power of a machine, in our laboratory, we use watt, and in the industry, we can use like a pumping machine, pumping water into your household. You use horsepower. So several things like that are not exactly the same, but they can be converted from one point to the other, so it makes it easy. You understand that in the industry, in the production of crude oil, in the industry, we measure our crude oil in barrels. They are measured in barrels. So, but in the laboratory, certainly we are going to measure our oil and our liquids in liters or centimeter cube, cm cube or meter cube. So we are not going to use barrel to grade or to graduate or calibrate measurement in the laboratory, because we are talking about large quantity, bigger quantity. So that is probably why the industrial measurement is a bit different from the local and the laboratory measurement. So we've talked about quantity. We said a quantity is a measurable property of a system or an object. It is expressed as a numerical value with a corresponding unit. Now, if I say 10 meters, 10 meters, 10 is a numerical value. The unit is the meters. So this is a quantity. The whole of this is a quantity. So the unit is a meters and the 10 is the numerical value attached to it. So a quantity must have a numerical value and a unit attached to it. So there are so many other ones. We will talk about. You have the fundamental quantity, then we have the derived quantity. That is the other aspect I would like us to talk about, the fundamental quantity and the derived quantity. What is fundamental quantity? What is fundamental quantity? What is fundamental quantity? So the fundamental quantity are quantity that are basic. Fundamental quantity are the basic quantities on which They are the basic quantities on which many other quantities quantities on which many other quantities depend on. So other quantities depend on them. So fundamental quantities are the basic quantities on which many other quantities depend on. We call them the fundamental quantities. Like the length. We talk about the length is a fundamental quantities. The length, which is measured in meters, the mass, that is measured in kilogram, the time, that is measured in seconds. These are fundamental quantities. They are the fundamental quantities. So the fundamental quantities. It is from these that nearly all the other quantities are derived from. We got all this one by adding this to this, putting them together. A combination of length and time, a combination of mass and length, or mass and time. Those just combination of them produce the other ones. So the fundamental, we call them the basic quantities or the fundamental quantity. The next one is the derived quantities. Derived quantities. The derived quantities are those quantities obtained. They are obtained or derived from the fundamental, or let's say from two or more fundamental quantities. Yes, they are derived from two or more fundamental quantities. So if you look at speed, let's take speed. Speed is a derived quantity. Speed is a derived quantity. I said they are obtained. Derived quantity are obtained or derived from two or more fundamental quantities, from some of these ones. They are more than this. You have the other quantities like electric current, temperature, amount of substance. So they are also fundamental quantities, but I didn't mention them. We have derived quantities now. Derived quantity like speed. Speed. What is speed? Speed is distance traveled with time. So we say speed is distance all over time. We all know that when you are talking about measuring distance, I earlier on talked about length, try to talk about length, that length is distance from one point to another. When you measure a distance, so a distance traveled or distance moved. When you look at this distance, if I measure a distance, from this point, Let's call this distance point, this place point A, and this place point B. Is that okay? From point A to point B is about 10 cm, 10 centimeter. Let us even assume it is 10 meters. Let us assume it is 10 meters. So, if it is 10 meters, we want to measure speed. What time will it take a child to run from point A to point B in 10 meters? Let us assume is 5 seconds. Remember, we were just saying 10 meters. 10 meters in 5 seconds. 5 seconds. 10 meters in 5 seconds. So the child speed is going to be 10 divided by 5, which will be 2 meters per second. So this would be the speed of that child. Now you can see that we said it is derived unit, because it is length, that is meter, time, that is the second, per second, that is divided. This one means inverse of this second. Inverse means 1 over s. M, meter, all over 1 times 1 over s, that is the minute, which means meter all over second. M times 1 is meter, that is m times 1 is m, 1 times s is s. So we have m all over s. And if you want to write this in an index form, like you are working on your indices in mathematics, we will talk about all those things later on in our mathematics class. So you write it like this: meter per second. That is how to do this. This is the unit of speed. This is the unit of speed. Remember that we said that we had the unit of length, which is meter, unit of mass, which is kilogram, unit of time, which is second. Then unit of speed is meter per second. That is ms raised to power minus 1. ms raised to power minus 1. That is the unit of speed. Now we talk about the unit of force. We talk about force. Force is a derived quantity. Force is a derived quantity. Force is mass times acceleration. Mass times acceleration. Sorry, I was trying to look at a different thing. Mass times acceleration. And the unit of acceleration, as we know, the unit of mass, as we know, is kilogram, which we know. Acceleration is meter per second square. Meter per second square. So if we put the two together, we have kilogram, the unit of force, kilogram meter per second square. In a better way, a single unit of force, we can just say Newton. Newton. Newton, which is capital letter N. They are the same. Another derived unit is density. Density. Density is mass all over volume. Mass all over volume. Mass all over volume. You remember that mass is in kilogram. Mass is in kilogram. Volume is meter cube. Meter cube. And volume that is meter cube is three lengths. Let's look at it. Let's assume you have this. This is volume. Let's say volume of a box or a cuboid. You have the length, you have the breadth, you have the height. So volume of a cube or a cuboid is equal to, volume of a cube is equal to length times breadth times height. That is the volume of a cuboid or a cube, a cuboid. So we can easily have the density of a substance, which is also a derived quantity. Volume is even a derived quantity. So meter cube is a derived unit. Meter cube is a derived unit. So density, the volume, the unit for volume in this way can be kilogram per meter cube. Kilogram per meter cube. So this is what we have for today concerning quantities, unit, and fundamental unit, derived unit. If you have any question, just post it to me. I want to thank you for listening up to this point, and please kindly subscribe to our channel so we could be encouraged and do more videos like this. Click the notification bell and press the like, share these videos. Let's reduce the rate of failures in our schools, and let's see how we can build up great scientists, great inventors, and great people. Thank you very much. God bless you.